What's up, guys? Welcome back to MVP Learners. Today we're going to be going over implicit differentiation. So we're going to go over a couple problems on how to do this. I tutor a lot of people in calculus, and this is something I see a lot of students struggle with. So I want to help you guys out. So let's work with this problem out. We have this function x squared plus y cubed equals 4, and we want to find the derivative, aka dy dx. We want to find that. And what we're going to do is we're just going to take the derivative of this, very similar to what we've done before, but there's going to be one little tweak. So when you take the derivative of each term, what you're going to do is, so this x squared, I'm going to take the derivative, it's 2x, but I'm going to put a dx over dx, because that's really what we do normally when we do derivatives. We don't write it like this. So dx over dx, that's just 1, so that can be ignored. We're not normally going to write that out, but I just wanted to show you. So then we're going to add that to 3y squared. I'm going to take that's from the derivative of y cubed, and I'm going to add this dy dx. So what this means is we're differentiating y with respect to x. Over here, I differentiated x with respect to x, which is redundant, but just wrote it out to show. And then we take the derivative of this 4, which is going to be 0. So I can ignore now this dy dx, or I'm sorry, this dx dx, and I can solve for dy dx. So we have 2x plus 3y squared dy dx equals 0. And then from here, we're just going to solve for dy dx. So I'm going to subtract the 2x over. So this will be 3y squared dy dx equals negative 2x. And then I'm going to divide it out. So then that's going to be left with dy dx equals negative 2x over 3y squared. So that is our answer. That is the derivative of this function. So you can also use implicit differentiation to find the tangent line. So just like we talked about in the last episode, to find a tangent line, you need two things. You need a point and you need a slope. So we're lucky enough that they gave us the point. We don't even need to figure out that. That'll just be 1 comma negative square root of 2. And then our slope, we'll just find dy dx, plug in this point to dy dx, and then just plug it into the slope intercept form. Or I'm sorry, point slope form. So let's get at it. We're going to take the derivative just like we did before. So we'll have 4x cubed plus 2y dy dx equals 0. Okay? So if you have any questions on how I did that, leave it in the comments below. But I think it's pretty straightforward. Then we're going to subtract the 4x cubed over to the other side. So that'll leave us with 2y dy dx equals negative 4x cubed. And then we're going to divide the 2 out on both sides. So that'll leave us with dy dx equals negative 4x cubed over 2y, which is going to equal negative 2x cubed over y. So then now, if we just plug in our point 1 comma negative square root of 2 into this, that's going to equal negative 2 times 1 cubed over negative square root of 2. So that'll leave us with negative 2. The negatives will cancel actually. So we'll just have a 2 over root 2. If I rationalize the denominator by multiplying square root of 2 over square root of 2, I will be left with 2 root 2 over 2, which is just going to be root 2. So our slope ends up coming out to square root of 2. It's nice. Everything kind of cancels out. So then now, all we have to do is just plug into slope-intercept form, which, man, I keep saying slope-intercept form. I mean to say point-slope form. That's going to be y minus y1 equals m times x minus x1. So it's going to look like this. Hopefully this looks familiar. If it doesn't, go check my last video I just uploaded. And then when we plug this in, we'll be left with y plus root 2 equals root 2 times x minus 1. So I'm just going to leave it like that. Don't forget the parentheses. And yeah, you could convert this into slope-intercept form, but I think it's sufficient to leave it in point-slope form. It ends up being the same thing. So that is the equation of our tangent line in this case. And the reason there's a positive sign here, for those wondering, is because if I do y minus y1 and y1 is negative, well, two negatives make a positive. They cancel out. So there you go. That is how to do this type of problem. So on screen here, this time we're going to be asked to find the second derivative using implicit differentiation. And I'm not going to lie, this is probably one of the hardest things you might be asked to do in Calc 1 or AP Calc AB. So buckle up. We're going to find the first derivative just like we did before. That should be pretty simple. So that'll be 2x plus 8y dy dx equals 0. So then we're just going to solve for dy dx. So that'll be 8y dy dx equals negative 2x. And then we divide out by 8y. So dy dx equals negative 2x over 8y, which is going to equal negative x over 4y. So now we need to take the derivative of dy dx to get d2y dx squared. So let's take that derivative now. So this is going to be d2y over dx squared equals, and then we're going to have to use the quotient rule. So low d high minus high d low all over low low, if you know that acronym. I'll make another video about quotient rule if you guys want me to. But anyways, so we'll put the denominator on top, 4y times the derivative of the numerator, so that'll be times negative 1. And then minus the numerator, so negative x, so minus high times d low, so that'll be times 4 dy dx all over low low, so that'll be 16y squared. Okay, so now we got to simplify this, and this dy dx here, this is going to be the trick you have to use with these implicit differentiation type of problems. You see how we have dy dx from the previous derivative? It's weird. We're going to actually plug this in to here. Okay? So I'm going to show you how this works. So now we just kind of simplify things. So this will be negative 4y minus, and then this will be negative x times 4 times dy dx, so times negative x over 4y. So I'll put everything in parentheses, don't worry, so we're not confused. Okay, and then all over 16y squared. I know it's getting nasty. It's getting nasty, I know. So then let's just simplify this some more. So this will be negative 4y minus, so the negative x times negative x, that'll make that part positive. Okay, that'll put an x squared on the top, and then multiply that 4, that'll also put a 4 on the top, so we'll be left with 4x squared over 4y squared over 16y squared. Okay, and then we can simplify that a little bit, so that'll be negative 4y minus x squared over y squared over 16y squared. Okay, but we're not done yet. We are not done yet. I know, I'm sorry. It is gonna keep getting nastier. Okay, so I went ahead and cleaned up the board here. One thing I should know, I made a little typo on the last screen. This should be just a y, not a y squared, okay? So now let's keep working. We gotta convert the numerator all under one fraction so we can simplify it. And the way we can do that is by just putting this negative 4y with the denominator of y, so we can subtract the two fractions. So that'll give us negative 4y squared over y minus x squared over y all over 16y squared. So then that'll be negative 4y squared minus x squared over y, and then that'll just be times 1 over 16y squared. Okay, so now what we can do is, if you notice, we have this negative 4y squared minus x squared. If we factor out a negative 1, I want you to notice something. If we factor out a negative 1 here, this is negative 4y squared plus x squared over y times all this. If you notice, this is the same thing as what we started with, right, up here, which is just 1. So we can actually substitute a 1 from the original equation into that, vastly simplifying our answer. And this is going to be a common pattern I want you guys to recognize that happens with these double derivative on implicit differentiation equations. So just keep that in mind. So when we do that, we'll have negative 1 over y times 1 over 16y squared, which is just going to equal negative 1 over 16y cubed. And that will be our final second derivative. So the second derivative, d2y dx2, that is going to equal negative 1 over 16y cubed for this example. Okay, so that was really nasty. That took me 3 different pages to get that. I hope they don't ask this to you on your tests because these are really nasty, but just in case, you need to be prepared. I remember doing these when I was in high school, so I threw this in here. I was debating whether to include this kind of problem, but I just decided you guys needed it. So anyways, that'll be it for me. Make sure to smash that like button down below, subscribe, and if you have any questions on this particular problem, because I know it was a hard one, let me know in the comments below.